Hi, my name is Johann Kruschwitz. I'm one of the developers of the GraphVar toolbox, and in this little tutorial, I'm going to speak about longitudinal brain network analysis with GraphVar. So longitudinal in our case means that we can analyze data that was acquired at 2 time points and make comparisons between those 2 time points, and also a little bit further inferences. For example, if we have 2 groups at 2 time points in an intervention, then we can also look at the interaction of time and the groups. So if something changed significantly between those groups with respect to our intervention that we performed, and so on and so forth. And there are different possibilities. And I'm going to go through all the 3 options that we have in GraphVar now in the next couple of minutes. So this is the regular user interface that I introduced in one of the other videos. And if we want to perform within subject analyses, we will have to first select an appropriate variable sheet. Here, this is ordered a little bit differently than the original variable sheet that we have in our sample workspace, but we provide you with a second one here. This is variables within design. I'm just going to load it up. And I'm going to show you. So we'll have to select those measures that we now want to analyze. And I'm going to show you in a minute how this variable sheet looks like. So this would be the variable sheet for the within design. The first column is always in GraphVar, will tell the program the scan ID, basically, so the subject ID, so that it can couple the files that you will load in to the measures, to the clinical measures, or to the demographic measures that you have in your variable sheet. So GraphVar will need to know, as usually, what the specific subject name is in here in the first column. But then, as compared to the other variable sheet where we do not have any within design, we have a second column that is only called subject ID. And here we see that for the first 15 subjects, we have ascending number, sample 1 to sample 15. But then again, it starts over sample 1 and sample 15. So this means we have 15 subjects which were scanned at 2 time points. And this is important because you'll have to indicate GraphVar here which subject it is. So GraphVar will work then subsequently by most of the time subtracting the values from T2 minus T1. So this is just for you to know. I'm going to explain in a minute what this actually means. So then those variables that you see here are basically similar to the ones when you do not have any within subject design, but obviously some things like sex or group would have to be repeated, right? So sample 1 is a female one, and then at time point 2, this wouldn't change. It's again a female one. And if you have maybe acquired the data within the same year, just a couple of weeks later, then the age also wouldn't change. For example, research site would also be the same, so this is repeating, but you could also then enter some variables, for example, like IQ, and you do an intervention giving some kind of drug or deep brain stimulation or some training for intelligence or whatsoever. Then you could also have the change of this respective variable, which we'll analyze now later on, given in here. And here you see for subject 1 at time point 1, the IQ was 100. And then if we go down here, the IQ decreased tremendously, so about half. So that was kind of a huge intervention, I guess. Okay, so this is just for you to know. You'll have to have the first column indicating the name that is similar as in your files, and then the second column telling GraphVar which subject is actually then repeating itself as a function of time. Okay, so we have now loaded in the variable sheet, and then we also have to select the data respectively. I'm going to do this here in our sample workspace. We have data, we have an additional folder, core matrix within design, and here you see it is ordered with the name exactly as in the variable sheet right now, sample 1A, and then it's going down, and no, it is here already here because it's ordered obviously alphabetically, sample 1b. So this would be time point 1 and time point 2. It is important that you name the time points so that they have an equal length of characters. I'm gonna show you in a couple of in a second why this should be the case. I open this in. Okay, I selected this my correlation matrix. And then here, as you usually know, we have to select the subject name in the file name. And this is subject sample 1A. And this is what I meant. The character length would have to be the same because it's now trying to read out or couple based on this character length, the subjects from your first column here, sample 1A and sample 1B to the data. And this has to be the same length, otherwise it couldn't match it. Okay, but this is now done. So what we'll have to do then, we'll, for example, here do some analysis with thresholding the network, sparsity range from 0.1 to 20% and 1% increases. And now just for the sake of it, we look at the global clustering coefficient and maybe also do some computations on the raw connectivity matrix. So what happens now, the first case could be that you just have two groups or one group of subjects and you do an intervention. So you're not interested in any interactions of, for example, a factor, for example, sex. So that the intervention would be different for males or for females. So, but now we're just interested in whether the intervention would work at all or whether there would be any differences. And specifically, we'll be interested in to see whether there are differences depending on the intervention. So time point 1, time point 2 on the graph theoretical metrics, here the global clustering. For doing this, we just have to select now the within subject ID and see this doesn't work now because I forgot to highlight the field in, when selecting the variable field. So I'll do this again. I'll select the variable field, indicating the second column. So second column, so the GraphVar can couple those scans, time point 2 and time point 1. I load it in again, and now we see subject ID is already loaded in here. And I have to tell GraphVar now what this ID is from being able to couple those files, time point 1 and time point 2. And here now subject ID is highlighted. I hit this button before, and now load in subject ID is our within subject ID. And now GraphVar will internally basically always compute differences by means of subtracting T2 minus T1. So in this case now the graph theoretic metrics, because everything will be calculated for time point 1 and time point 2, for each subject is now subtracted the global clustering from time point 2 minus global clustering from time point 1. So we'll get a difference measure essentially in the end. And then we don't have to do anything else, not load anything in here, because we already defined that our within subject variable would be the subject ID. If we then simply hit on calculate and statistics, GraphVar will start to run, and it will internally perform this subtraction procedure and then perform a test against 0. So this is basically equivalent to a paired sample t-test, what you would want to apply in this case. But if you perform the subtraction beforehand, so subtracting time point 2 minus time point 1, then you have basically a difference value, a mean value, and then you can simply test whether this is significantly different from 0. And this is what's happening here. And as we have set up a GLM, this mean will be encoded here in the intercept term. We look at the clustering, and what we see here now would be the difference of the two time points. So time point 2 minus time point 1. And we see the difference is really, really low, and it's not showing us a difference, so not a D in here, but it's showing us an M for mean, because we have subtracted time point 2 minus time point 1. We have basically the difference value and testing whether this mean would be different from 0, but it's not different from 0. So we know that our intervention in this case for the global clustering was not so efficient, so it didn't cause any changes in the global clustering from time point 1 to time point 2. And it's important to know that we subtract T2 minus T1 for being able to interpret this difference score. Okay, the same would now count for the correlation area. So we would have here again those difference values, and we would see what is significantly different by hitting the hide non-significant button. Some are deselected, and here we could, for example, see that in the occipital superior and the frontal superior orbital L area, there the difference would be significant. And we know that time point 2 is subtracted minus time point 1. Here we have a positive value, the m, the mean value. This means time point 2, the connectivity, because we are looking here now only at connectivity values, not at the clustering, must be bigger at time point 2. So there was an increase in connectivity across time. Okay, so this is basically the first option that we can do. Now I'm going to hide this again. The second option is also presented in this little presentation that is in the download folder of GraphVar. This is the GraphVar Turbo GLM tutorial. And here within subject design sample 1, where we can investigate the association between a constant independent variable, for example, sex, and a changing dependent network variable. So this is what I meant with we could be interested in looking at whether there would be an interaction effect of sex, so male versus female, with respect to our intervention, right? Then we're interested in this interaction of group by time. Okay, how would this work? Here it is still important that we have loaded in the subject ID, because GraphVar would need to know how to couple those scans of the 2 time points. But then we simply drag sex, which is a between subject factor, as I explained in the previous video, where I explained in the end a little bit about the GLM and how this works, simply in the between factors field in here. So now GraphVar is still beneath its hood operating with those differences, and this means the following. It will, for the male group or for the 2 groups respectively, it doesn't matter who you load in. I can also now show you an example later on with the research side where we have 3 groups. The same may count for this. But if we just have 2 groups, it will calculate the global clustering for time point 2 for all the subjects in the female group, and then subtract time point 1, so the global clustering from time point 1 from the global clustering in time point 2. This essentially means that we compute a difference measure for each of the groups, as we previously just did in the other example, where we are not interested in any group difference, but just want to see whether an intervention was successful or not. So in the end, what we'll have then is a difference value for the 2 time points, T2 minus T1, for the males and for the females. And this is now the simple part in interaction is nothing more than the difference of the difference. So if we compute the difference for the males for time point 2 minus time point 1, and compute the difference for the females time point 2 and time point 1, we can simply take the difference of those 2 difference measures. And this is what the interaction is. So we will run this, and I'm going to show you how this looks in the results viewer. So now it's done. So GraphVar is finished now, and we can select our variables here. This would be sex, clustering coefficient, and select all the thresholds. And what we see here now on the x-axis is from the other videos, those are the network thresholds. And here is our critical value. So this in our case, and I'm gonna make this window a little bit smaller, so because I think we cannot see everything on the screen share. Now you even have those little selection windows here at the bottom. So this is the respective measure of interest, which by this definition of this formula is our interaction. So I've told you that internally GraphVar is computing the difference of T2 minus T1 is doing this for each of those groups. And what we see here is the difference of those differences between those groups, and therefore the respective interaction of group by time. And as you see here, those little dots which are not full, they are not significant, but here, these are significant. So as I showed you in the previous videos, this is one indicator whether something would be below the respective alpha level that you can put in here. So we know here at those two thresholds, and even at these thresholds, the difference of the differences would be significantly different from 0, which is an interaction by group by time. So right now, we do not necessarily know in which direction each of the group goes, or how the clustering of each of the groups changes depending on the time. We just know that the change between the groups is different. But we can find this out if we look at the hide show group value button here. And the upper line is the one for the males, the lower line is the one for the females, and this is this respective difference of the different scores, T2 minus T1, which are incorporated already in this line. So if we now look at this a little bit closer, and here you have to think with me and wrap your head around it. So this is the difference of T2 minus T1. So this is positive, which means that the males have an increase in the global clustering on the threshold from T1 to T2, right? Otherwise, it wouldn't be a positive value. If we look at the same thing here, females is negative, which means, and we are also computing internally T2 minus T1, that they actually have a decrease in the clustering due to this intervention. And because this difference is there based on the increase in the males and the decrease in the females, it is significant interaction. And I can show you here in this little slide, which I just found in the internet, the interaction we have now been looking at would be similar to an ordinal interaction, where factor A would be the time, T1, T2, and we saw that in the males, it is actually a positive difference, and we're subtracting T2 minus T1, so it's going up, and in the females, it is a negative difference. So this would be the effect we're actually looking at here in GraphVar at those respective thresholds. And as we can follow along the entire threshold range, even here, it would be an ordinal interaction. We can toggle then here and look just respectively at the value for the respective groups. Here's the female group, T2 minus T1, and here's the male group, T2 minus T1. So basically it just zoomed in and it's not showing us the difference score, but just the regular subtraction term for each of the groups separately, and then we are adding here the difference score, the difference of those differences again, which is our interaction. The same now counts for the correlation area. So those are all, and now we're speaking about functional connectivity values, no, not clustering coefficient anymore. We can again hit the hide non-significant button, and those significant differences of the differences just tell us that something is going on here. But we would now need to, again, as I showed you in the one-dimensional variable with the global clustering coefficient, first examine which direction those differences for the respective group have. So we'd basically have to do it the same way as I showed you in the interactions. So I'm gonna close this now, and I come to the next case, which I also show here in this little tutorial. Go a little bit down here. Here we can investigate now the association between a changing independent variable. So this could be IQ, as I showed you in the beginning. In the variable sheet, there seems to be a drastic decrease in IQ depending on the intervention we did, and also the change of the dependent network variable. So it could be that the global clustering changes depending on our intervention from T1 to T2, but also the cognitive function changes from T1 to T2. And then we will be interested in whether there is an association or an interaction of the change of the global variable, global clustering, so the graph theoretic metric, or even functional connectivity, to the change in cognitive function. And this is relatively simple. Here we just then add IQ, and IQ is a continuous variable, so we drag it in the between covariates field. We still have the subject ID highlighted as a within subject ID, and if we do not want it anymore, just showing it for the sake of it, we can clear it and we can load it in again. So this was just to demonstrate the clear button. Now, everything is the same as in the previous examples. I'm gonna click calculate and statistics. And now GraphVar again internally is computing those differences. So it is for IQ, again, computing the difference of the values from T2 minus T1. So we have a difference value for IQ. And for the graph theoretic metrics, but also for the functional connectivity, as we opted to do this on the raw matrix, it'll also compute the difference of T2 minus T1. So in the end, we're interested now on the influence of IQ, or the change of IQ on the change of the respective network variable. Highlight everything. And we see there's nothing significant right now. But the most important thing, just to explain this, we do not see an M for the mean as we had in the previous, in the first example. We do not see a D for the difference, but we see a B because we are setting up the GLM, and the B is the beta estimate, so the regression, the regression weight for the regressor that we're trying to explain the change in Y. The change in Y would be here the change in the global clustering, but the regressor that is put in by GraphVar is the difference score of IQ. So the difference of IQ in T2 minus T1, and we're trying to explain now the change of the network variable, which is also computed internally with GraphVar by this regressor, which represents the change of IQ. So therefore, we have a beta because it's essentially a regular regression we set up here. And we see nothing is significant. We can, again, look, for example, here at the correlation area, hide the non-significant, and we see where the change of IQ, so of our cognitive variable, would be significantly associated to the change of, in this case, it would be functional connectivity. And we see here, this is just sample data in the olfactory and connection between the olfactory area and the middle frontal right area. Okay, so that's basically it. I'm just going to show you, because I told you we are also able to not only compare two groups, but automatically look at three groups. So research site is encoded here in the within variable sheet with 3 sites. So we have, let's look again, New York, Paris, and London. So this would not change between the 2 time points, but we can see whether there would be any significant difference now as a function of time between those research sites with respect to our intervention. We just hit the calculate in statistics button, and now it is calculating everything again. And we just look at research site, global clustering, highlight everything. And then we have a different formula in here, which is research site is 0. And this would correspond to the F value if we compute an ANOVA where an F value, a significant F value, would indicate that there is somewhere among our groups a significant difference. But here, research site is not significant, so that it seems as if there is no difference between the groups. We can leave this highlighted and show the group values, and we see they are really adjacent to each other, so there is not really probably a real group difference, which we see here in the F value. We can then toggle to the mean of the respective group, London, so which is again the difference of T2 and T1 here in the clustering, New York and Paris, but they seem to be really close together. And then we can look at the respective pairwise comparisons. T2 minus London minus New York, and as I told you in the example with gender, it is internally now computing for London T1, T2 minus T1, and for New York the same. And we're looking at this difference score, which is the difference of the difference, so the interaction of group and time. And we can look at the pairwise interactions, but we know that from the research side here, 0, there is no significant, or yeah, probably no significant group difference among our 3 groups. We can again look now here at our global functional connectivity matrix, do the same as I showed you previously. Here we see behind those little cells, there would be no significant group differences. Here we see an F value, which I told you is similar to the ANOVA, and we have the degrees of freedom, right, corresponding. And then we can actually look at whether in those little cells here there would be significant group differences when we go to the pairwise comparisons. Okay, so that's basically it. Thanks for watching, and if you have questions, do not hesitate to contact us. Bye-bye.